Hi everyone. Today I and my partner Tấn and Phi will make a presentation about solar energy and MPPT using piano algorithm to reach the maximum power point. Our presentation has four parts. Part 1 is introduction. I will introduce about solar energy and MPPT, maximum power point tracking. And part 2, we go to theory of MPPT. I will explain why to need MPPT and how piano and MPPT algorithm works. And we get to part 3, simulation. My partner Phi will show us the simulation on MATLAB and then he will make a conclusion. I go to part 1, introduction. Solar energy is green energy from the sun, and it's called green energy because it doesn't emit polluted smoke into environment, and moreover it's renewable energy, which means it never runs out. Solar panel convert light into electricity, and MPPT, maximum power point tracking, and as the name suggests, it will track maximum power point. Part 2 is a theory of MPPT, and this part have these contents. First, we need to have an overview about our system. Then we discuss about physical modeling of PV generator, and next we have equation of PV generator, and we will talk about buck converter. You know, it's a step down voltage converter. And then we get to piano MPPT algorithm. We have introduction and steps, and you just follow these steps and piano algorithm will work. And stopping condition of MPPT algorithm piano. Finally, I will make a brief review. We get the system overview. The system consists of a solar panel. A solar panel also as known as a heart of the system. A buck converter, a battery which always consume 48 volt, and MPPT as known as the brain of this system. We get to model of PV generator. PV cell connect together form a solar panel and light shine on them, and then create voltage and current. We have PV equation like this, and almost all of them are parameter, but only two variable is voltage V and current I. Then if we use this formula I equal P over V, we will have an equation which is the relationship between power and voltage. Then we can have the characteristics power and voltage. And as you can see, it's a curve. It's non-linear. It's a curve. And our task is to find the maximum power point. It's somewhere in the middle of the graph, and it's here. We get to buck converter. The buck converter reduces the voltage by formula V output equal D times V input, which D is duty cycle. This is from 0 to 1. With V output is with V output equal 0. Sorry, with voltage output equal 48 volt, because our load is battery which always consume 48 volt. So we have VI equal VO times over D, V output over D. And because V output is constant equal 48 volt, so we just control duty cycle D. We can control VI, which is which VI is the output power of solar panel. Next, I will introduce piano and MBBT algorithm. MBBT finds the maximum power point. It changes the voltage to get more power. For instance, you go to the right side. You are here. You go to the right side, and you see the power increase. You get higher power, so you continue to go to that direction. But if power decrease, you must change direction. Now we get to step of piano algorithm. Step 1, we measure to get voltage and current. And step 2, we calculate power by formula P equal V times I. Then we get to step 3 and 4. We compare power with previous power, voltage with previous voltage, and we change duty cycle by delta D. For example, if power increase when voltage increase, we should continue increase the voltage, and if power decrease, we must change direction. And we change voltage by add or subtract delta D from D. And we get to the stopping condition of MBBT algorithm. The algorithm stops when power does not change. Delta power equals 0. It's absolutely equal. It can't absolutely equal 0, but only approximately equal 0. Approximately. At this point, the maximum power point is reached. Now it's the times of it's the phase time.